All right, guys. Well, I'm sorry I can't be there in person tonight. I emailed Sue and I'm feeling very lousy, so I'm going to go home uh, today after Elk Lake and just get some sleep. But I wanted to get you a worksheet and a lesson on the trigonometric ratios. And what I want to do is spend some time looking at these. They're about 9 slides. And the homework assignment which I sent to you is an application of all of these things. So let's go have a little review of things, and then we'll go ahead and we'll take a look at some problems. Last time when we met, we talked about triangles, and we talked about right triangles, indicated by that little block there representing the 90-degree angle. Remember, I said also the hypotenuse is always going to be opposite that 90-degree angle, and the hypotenuse in this case is going to be the longest length of any of the legs in the triangle. So, and we talked about this relationship, and we said that a squared plus b squared is equal to c squared. So we're talking about using these any two sides of a right triangle to find the third side of the right triangle. And we also talked about relationships within the triangle. And those relationships were as follows. If I have an angle, and that angle, let's just call it, well, it's opposite side B, so let's call it capital B for our angle. So I'll say that angle there, we can characterize by some relationships between sides of this triangle. And those relationships were the following. The sine of angle B, the cosine of angle B, and the tangent of angle B. Well, the sine is the opposite. Hang on one second. If I take my angle and I draw opposite the angle, that's going to be the side that is the opposite to the angle. So that's going to be the opposite side, B, over the hypotenuse, C. Sine is opposite over hypotenuse. Okay, that's the so in what they say SOHCAHTOA. The cosine of angle B, let's get rid of this line here, because we're not interested in the opposite anymore, but we're interested in the adjacent side and the hypotenuse. Now, the adjacent side of angle B contains that angle. So that's going to be the adjacent side. It's part of the angle, right? So that was A. I erased that, I guess. That was side A. So the cosine of B is going to be the adjacent side over the hypotenuse. In this case, C is the hypotenuse. The tangent was the last trigonometric ratio that we are examining, and that's going to be the opposite over the adjacent, or B over A, if I'm looking at that. Now, let's go ahead. First of all, let me relabel that with a black marker so we're consistent. Let's look at the other angle in this triangle, angle A. Now, angle A also has an opposite side and an adjacent side. In this case, the side opposite angle A is little a, and the side adjacent to angle A is our B. So let's look at the sine, cosine, and tangent of angle A. Now, first of all, I forgot to tell you, the cosine is adjacent over hypotenuse, and that's the ka in SOHCAHTOA, and the tangent is opposite over adjacent. So they always say that SOHCAHTOA. I don't know. They say it sounds like some sort of a indigenous word, but um, I don't know. You can just remember it like that or like this, just as easy. So let's go ahead now and look at our other angle up here. Let's get rid of this stuff. Because we have two angles. We have angle A and angle B. Let's take a look at angle A. Well, the sine of angle A is the opposite over the hypotenuse. So in that case, it's going to be whatever the length of A is divided by the length of C. The cosine of A is going to be the adjacent over the hypotenuse. And the tangent is going to be opposite over adjacent, A over B. So we have those relationships for that angle. So we have a couple of different ways to solve problems here, using the Pythagorean theorem, a squared plus b squared is equal to c squared, or using these relationships. For any angle, I forgot to tell you last week, or I just didn't get time to tell you, let's draw a right triangle again. And let's just say, okay, this is A, B, and C. And so for this angle here, if I'm looking at an angle, there's something interesting. There's another interesting mathematical relationship that we should know. If I know the sine of angle B, and I square that, sine squared of beta of B plus cosine squared of B, that's going to be equal to 1. 1. And we can prove that. Let's pretend this is a 45, 45, 90-degree triangle. Right? So we learned our special triangles, and this is a special case of an isosceles triangle, 45, 45 degrees, and 90 degrees, of course. And let's say that our length here is 1. Our length there is 1 unit. Could be 1 foot, right? And this would be, using Pythagorean theorem, 1 squared plus 1 squared is equal to 2. So my hypotenuse would be the square root of 2. Because a squared plus b squared is equal to c squared. So if c squared is equal to 2, then c is equal to the square root of 2. Okay? All right. Now, we're going to prove to ourselves that the sine of an angle squared plus the cosine of an angle squared is equal to 1. Let's take a look at this angle. The sine is opposite over hypotenuse. 1 over root 2. I'm going to square that. Plus the cosine adjacent over hypotenuse. 1 over root 2 squared. Well, what does that equal? If I square the numerator and the denominator, well then I'm going to get, let's see if we can put the screen down a little bit. I'm going to get 1 squared is 1. Square root of 2 squared is 2. Plus 1 squared is 1. And the square root of 2 squared is 2. So 1/2 plus 1/2 is equal to 1. And for any angle, that works. It could be 30 degrees. The sine squared plus the cosine is equal to 1. It could be 60 degrees. The sine squared and the cosine squared is equal to 1. So it's all the same, as long as you're looking at that angle. So let's go ahead and take a look. I'm going to try to shrink myself down a little bit. And hopefully this is working the way I'm recording it. Let's take a look at some of these problems. So let's make it a little bit bigger, and we'll go ahead and take a look at some problems. This is not really a problem, this slide. This is just telling you, I'd say, hey, if I'm standing here and I know the angle and the distance from how far I am from the building, I could tell you how high the building is, and I could tell you the length of this distance from which I'm viewing because of all of these ratios. So it says here, oops, trigonometry, the study of triangles, can be used to solve problems involving right triangles. And many times we're using it to find height of something. Now, next week when we meet, we'll be talking about triangles other than excuse me, other than right triangles. So let's take a look at this slide. This is a very bad drawing, but let's read the question and we can redraw it. It says, a ladder is leaning against a building as shown to the right. Actually above here. And it says, the ladder reaches a height of 5 times the square root of 3 units on a building. And the ladder makes a 30-degree angle with the wall of the building. Let's redraw that. So we're going to say ladder has a height, and then I'll zoom out on this when we get to it. So here's my building, let's say, and the ladder's leaning up against it, and the height is 5 root 3, and we can just leave that alone. We can do it on the calculator later if we need to. They want to know the angle this makes with the wall, we're told that this makes a 30-degree angle with the wall, 30-degree angle with the wall. So they want to know the angle it makes with the ground, and they also want to know the length of the ladder. I'll call it L for length of the ladder, and they want to know this distance here, how far it is from the wall. So let me bring my screen back up. So here's my picture. Let's see if we can get a little closer. So we can find all of these things. We know that the 30 degrees is this angle here. And we know what would be the adjacent side of that angle. And we are looking for the length. So once again, if I want to redraw that, we can just picture the triangle looking like this. Now this is not going to be a good scale drawing, but it's just a cutaway of this part of it. This angle is 30 degrees. This is 5 times the square root of 3, and they want to know what that is. So we know the relationship that the sine of 30 degrees is equal to, I'm sorry, I want cosine here, because I have the adjacent side. The cosine of 30 degrees is equal to the adjacent over the hypotenuse. So that's 5 times the square root of 3 over L, the length. So let's get a number for the cosine of 30. I'm going to pull up my calculator. And let's clear this. Hopefully I want to make sure I'm in degrees, not radians. So let's see here. I'm going to look over mode. And unfortunately, I am in radians. So you have to go down, if you have this kind of calculator, to degrees. And now you're set. So I'm going to go cosine of 30. Oops. Cosine of 30. And that's not it. This did not go to... Oh, I'm still in radians. Hang on. I'll go to mode. I'll go down. Radians. And that should do it. Flashing on degrees. Should be right here. What's going on here? Okay. I'll hit enter and see what that does. Okay, second quit. Let's try this again. Okay, radians are something different than degrees. They're measured differently. So I'm going to go cosine of 30. There we go, 0.866. Okay, 0.866. So the cosine of 30, 0.866. That's going to equal 5 times the square root of 3 over L. So let's switch L and 0.866. And that will give me my answer. So go ahead and do it. 5, and then I'm going to multiply that by the square root of 3. And I'm going to divide that by 0.866. And you get 10. So the length of the ladder is 10 units. Okay. This is interesting because when you study trig a little bit further, you understand that the cosine of 30, you learn the value of it. It's the square root of 3 over 2. Okay, so if you would have known that, I could show you the I think I did show you the special triangle for that one. If we had put the square root of 3 over 2 down here, the math would have worked out to 10 as well, because that would cancel with that, and that 2 would come up, multiply by the 5, and we would just get 10 for our answer. So hopefully you're able, we can talk about that next time. So that's how we did the problem. So we get an L of equal to 10. Okay, pretty straightforward. I'm going to pause this to see if the recording's coming out, because I'm switching back and forth between a lot of things. And if it's working out fine, I'm going to follow up with a video with more problems for you. So just hang tight.